Hi class, this is course 3, lesson 18, lines and angles. Okay, now there is a lot of information that you need to write down in this lesson, and so to keep the video as short as possible, I'm just going to talk really fast. So if you want to copy everything down right now, press pause, copy, and then resume, and I'll talk through it real quickly, and then I'll move on to the next page. Okay, so we have item, characteristics, looks like, and the symbol. Okay, so we have a plane, a two-dimensional flat surface that continues forever. And what that's going to look like would be a wall. However, the wall would continue forever in each direction. So like to the left and to the right and up and down. It wouldn't stop with like the floor or the roof or the other walls. It would continue on forever. And there's no symbol for that. We also have points. It is an exact location, and it's going to look like this. It's going to be a dot, that's the point, and then we name it using capital letters. So point A in this example. A line is a collection of points. It continues in both directions forever. Okay, so this is what it looks like, and notice we have arrows on the ends. That tells you that it continues in both directions. That's a line. And the symbol that we're going to use is capital letters still, and we can name it BC, or we can go CB. We can go in either direction. We can go B to C or C to B. It's still the same line, but notice that we have this line-looking symbol above those letters. That tells you by looking at it that you are dealing with a line. A ray has an end point, and it continues in one direction. Okay, so here is a ray. It has an end point at E, and it goes through point D. Okay, so that's the direction. When we name it, this arrow always goes to the right. Always goes to the right. Let me see if I can write that down for you here. This arrow always to the right. Okay, now notice that our ray goes to the left. That's okay. Rays can go in any direction they need to go in, but we always put that symbol with the arrow telling us that it's a ray to the right. But you start with the end point. Okay, so notice our end point was E, so we put E at the end point of the ray, and D is the direction that the ray goes through. A segment is part of a line. It has two endpoints. Looks like this. Notice there are no arrows that continue. It could have arrows. If I go back up here, we could, at this line, this is a line, but we do have a definite segment between B and C. Okay, and the way that we differentiate that segment from a line is by making just a bar above the letters, so it's F to G or G to F. And notice without the arrows, it ends there. Those are endpoints. So a segment I can name in either order. A line I can name in either order, but the ray has to always start endpoint and then the point that it goes through. Now an angle is formed by two rays with a common endpoint. That's called a vertex. So here I have an angle. I have ray HI and ray HJ. And the way we name it, we use this little angle symbol, and we can name it with just the vertex H, unless there's another angle that has a vertex at H. Then we need to label it with the three letters, and we can start on a ray and go to the vertex and to the other ray. So it would be IHJ or JHI. Either way, that still designates the same angle. Now sometimes you'll see angles that have like a number in here. Maybe it's a 2. Then we could also call it angle 2. Okay, so there are several different ways that we can name these figures. You just have to use the right symbols with the right items. Okay. Here's another grid that if you want to write down and then listen to me, just pause the video and write what you see. 4 types of lines. We have parallel lines. They do not intersect, and here are the 2 parallel lines that I've drawn for you. We have line PQ is parallel to line RS. Okay, so this symbol right here, you're going to need to know that. The 2 vertical lines really close to each other. Kind of looks like the 2 L's in parallel. That means parallel lines. They will never intersect. Perpendicular lines, they intersect at 90-degree angles. So now we have right angles. And they'll have that little box there. So we have line LM is perpendicular to line JK. So this symbol here is what you need to know. That shows that we have perpendicular lines. Oblique lines are neither parallel nor perpendicular. They intersect, but there's nothing special about how that happens. And skew lines are lines in 2 planes, and they do not intersect. So if you think, you know, of a line on the ceiling and a line on the floor, the ceiling is a plane, the floor is a plane. If you have a line in each of those, they'll never intersect. That's what we're talking about with skew lines. Okay, another time that you can pause the video and listen after you have everything written down. I do have some more to write here in this 4th one, but that would be at the end, and so you'll be fine there. We have an acute angle, angle TUV, or angle U, or angle VUT. Measures more than 0 degrees and less than 90 degrees. That's an acute angle. Right angles are going to have the little box there, or they'll tell you that they are perpendicular. They measure exactly 90 degrees, and in this case I called it angle M, but I could also call it NML or LMN. Obtuse angles measure more than 90 degrees but less than 180 degrees. Okay, so they're a little bit bigger than a right angle, but not completely flat yet. Straight angle, in this case we have angle DEF. Straight angles measure exactly 180 degrees. They form a line. Okay? Now, where we have, this is where you're going to need to write something. This right here, this linear pair, that's when you have 2 angles that form a line. So in this case we have angle DEM and angle MEF. Okay, do you see that? We have this angle here and this angle here, and they make a line. So they are a linear pair. Okay, the sum, here's another thing you need to know. Because they're a linear pair, their sum is going to equal 180 degrees. Okay, a straight line is always 180 degrees. So we know that this angle plus this angle will be 180 degrees. Linear pair makes a line. Okay, you can see the word line there. Pair means 2, linear means makes a line. Okay, so angles are measured in degrees. A full circle is 360 degrees. A semi or a half circle is 180 degrees. And we know that that's a straight angle. This tool right here is a protractor. That's what we use to measure angles. Okay, so this M, find M, angle LMN. This tiny little m, lowercase m, means the measure. So when you see that lowercase m in front of a segment or in front of an angle, it means measure. So they want you to know, want you to figure out how long it is. So how do we use a protractor? So first off, LMN. So LMN. So I need to find from here to here, right? I'm finding that piece of a circle. I'm finding how big that measures. So step one, to measure an angle, we're going to put the center point of the protractor on the vertex of the angle. And the center point is right here, that little open circle. That goes on the vertex. Okay, so if I can move that down and put it on the vertex. Okay. Then we line up one of the rays with a 0 on the protractor. Okay, so I have a ray here and I have 0 there. So I can, let's see if I can spin this a little bit. I don't know if I can that fine tune it that much. I know you can on when you're using the protractor, but I don't know if it'll let me. Alright, so it's not going to let me. So you get the idea. This should be flat on with 0, and there's also another little line right here that'll help you line up closer to the center point. So we're going to line one of the rays up with 0 on the protractor, and remember you can spin the protractor if you need to. And then we're going to locate the other ray on the protractor. So the other ray is over here, right? Right there. And then we're going to measure. So we're going to start at 0, and notice how we have two sets of numbers. One starts at 0 on the inside and one starts at 0 on the outside. So make sure you know which side you're measuring on. In this case, we're going to be on the inside number. So starting at 0 and going around, it's between 150 and 160. So if I look out here, it'd be 151, 2, 3 maybe. If I need to extend the ray, I can. That doesn't hurt anything. It doesn't change the angle. I'll call this 153 degrees. 153 degrees. So that's how you measure an angle. The other thing that might happen is if your angle is at a weird angle, you can, like I said, just pick up your protractor and spin it around, because we could do the same on this side. Let's see if I can line it up. Okay, so I could go this way and put that center point on the vertex and line up this point with 0, and then count, go around on the outside now between 150 and 160, 153. One way that you can check to see if you've used the right set of numbers, or that you're close, is that look at this angle. It's an obtuse angle. I know that obtuse angles should be between 90 and 180, so 153, I'm probably pretty okay. If I would have come up with 33 or 27, then you can say, whoa, something went wrong. Okay. That's all for lesson 18 today. I know I went through it really quickly and there was a lot to write, so if you have questions, please let me know.